Right now, as you watch this video, space itself grows bigger. Every second that passes, the distance between distant galaxies increases by thousands of miles. Yet this expansion happens without expanding into anything at all. Today, we dive into the most mind-bending truth about our universe, a reality so strange it breaks everything you think you know about space, time, and existence itself. Picture this moment. Between you and the nearest star, empty space stretches like invisible rubber. The gap grows wider every heartbeat. Space creates more space from nothing. This isn't science fiction. It's the shocking reality of our expanding universe. We'll discover why every point in space believes it sits at the center of everything. We'll witness the invisible force that makes up most of reality. We'll confront the disturbing math that predicts how everything ends. Most importantly, we'll answer the question that haunts every curious mind. If the universe expands, what does it expand into? The answer will shatter your understanding of existence itself. If you want more tips like this, make sure you hit the subscribe button. We begin. Empty space isn't empty. It's not nothing. Space represents the stage where all physics happens, and this stage grows bigger every moment. When you look at the gap between stars, you're seeing something that stretches like cosmic dough. Think about blowing up a balloon. The balloon expands into the room around it. The room provides space for the balloon to grow. But our universe contains all the room there is. It expands without needing anything to expand into. Imagine living on the surface of a balloon with no ability to see up or down. Your entire world exists on that curved surface. As someone inflates the balloon, every point moves away from every other point. From your view, space itself grows. There's no outside for your flat world to expand into. Now add one more dimension. We live in three-dimensional space that expands exactly like that balloon surface. We can't see beyond our 3 dimensions. Space expands within itself, creating more space as it grows. This expansion happens everywhere at once. Between your atoms, the expansion force is too weak to overcome the forces holding you together. Between stars in our galaxy, gravity wins and keeps them bound. But between galaxy groups separated by millions of light years, nothing stops the endless growth of space. The numbers are wild. Every second, a region of space 1 million light years across grows by about 70 feet. That means galaxies millions of light years away race away from us at hundreds of thousands of miles per hour. Not because they move through space, but because space carries them along for the ride. Edwin Hubble first discovered this cosmic expansion in 1929. He found that every galaxy outside our local group moves away from us. The farther they are, the faster they flee. But we're not at the center. Every galaxy sees the same thing. Edwin Hubble looked through the world's largest telescope in 1929, expecting to find a calm, unchanging universe. Instead, he saw cosmic chaos. Every galaxy he studied raced away from our Milky Way like fleeing refugees. The faster they moved, the farther away they lived. This discovery destroyed everything scientists believed. Einstein himself thought the universe stayed fixed forever. When his own math predicted expansion, he added a fudge factor to keep everything static. He later called this his greatest mistake. Hubble measured galaxy speeds using a clever trick. Every element produces light at specific colors when heated. Hydrogen glows red at a precise wavelength. These cosmic fingerprints never change. But Hubble found something impossible. The familiar signatures appeared stretched toward red. The farther away a galaxy sat, the more its light shifted red. This red shift revealed that galaxies moved away at incredible speeds. A galaxy 2 million light years away moved at 30 miles per second. A galaxy 4 million light years away fled at 60 miles per second. Double the distance, double the speed. The pattern held everywhere Hubble looked. He called this Hubble's law. Today we know the constant equals about 45 miles per second for every 3 million light-years of distance. The implications staggered astronomers. If everything moves away from everything else, then long ago, everything was much closer together. Trace the expansion backward, and all matter squeezes into a single point. This led to the Big Bang Theory. Hubble's discovery meant our universe has an age. Space began expanding 13.8 billion years ago from an incredibly hot, dense state. Before that moment, neither space nor time existed as we know them. Even more disturbing, Hubble realized that galaxies farther than about 14 billion light-years flee faster than light itself. These cosmic refugees cross the ultimate speed limit, disappearing beyond a horizon we can never penetrate. Modern telescopes confirm Hubble's findings with incredible precision, supporting the shocking truth that our universe expands relentlessly. Grab a balloon and draw dots across its surface. Label each dot as a different galaxy. Now slowly inflate the balloon while watching your cosmic map. As the rubber stretches, every dot moves away from every other dot. Pick any that you labeled Milky Way. From this galaxy's view, all other dots race away in every direction. The nearby dots move away slowly. The distant dots flee faster. Every galaxy appears to escape from your chosen center point. Here's the mind-bending part. Move your attention to any other dot. From this new view, every galaxy races away in all directions. This new galaxy now appears to sit at the center of expansion. This balloon shows why every observer sees themselves at the center of the universe. There's no preferred location, no special cosmic address. Every galaxy experiences identical expansion patterns. The balloon reveals another crucial truth. The galaxies don't move through space. The balloon material carries the dots as it stretches. Similarly, space itself expands and carries galaxies along for the ride. Galaxies stay relatively still in their local patch while space grows around them. This explains how galaxies can appear to move faster than light without breaking physics. The speed of light limit applies to objects moving through space. It doesn't limit how far space itself can grow. Consider a galaxy 15 billion light-years away. Space between us expands so fast that the galaxy recedes at 1.5 times light speed. The galaxy itself moves very slowly through its local space, but expanding space creates the incredible recession speed. The balloon model has limits. Real balloons expand into surrounding air. The universe expands into nothing. Real balloons have inside and outside surfaces. The universe contains all that exists. We must imagine a balloon with only its surface, where inside and outside don't exist. Our three-dimensional space behaves the same way, growing larger without needing extra dimensions to expand into. 13.8 billion years ago, the universe measured smaller than the period at the end of this sentence. All matter that would form hundreds of billions of galaxies squeezed into a region tinier than a proton. The temperature reached numbers so large they break our ability to understand. Then expansion began. The first moment defies understanding. There was no space to expand into. There was no time for events to happen. The concepts of before and after had no meaning. Space and time sprang into existence along with all matter and energy the universe would ever contain. Scientists call this the Big Bang, though the name misleads. Picture a giant explosion hurling debris outward through empty space. That image captures nothing about what actually happened. Space itself began expanding. No explosion occurred because there was nowhere for an explosion to happen. Within the first second, the universe underwent the most dramatic change in cosmic history. During inflation, space expanded faster than anything science has measured. The universe grew by a factor of at least 1 followed by 26 zeros in less time than light takes to cross a proton. This inflation solves cosmic puzzles. The universe appears remarkably uniform in all directions. Distant regions that could never have communicated show identical temperatures. Inflation explains this by stretching tiny uniform patches to cosmic proportions. After inflation ended, the universe remained incredibly hot and dense. For the first 380,000 years, space glowed like the inside of a star. Free electrons scattered light in all directions, making the universe completely opaque. Then came recombination. The expanding universe cooled enough for electrons to combine with atomic nuclei for the first time. Suddenly, light could travel freely. The universe became transparent and the cosmic fog cleared forever. That ancient light still travels today. We call it the cosmic microwave background radiation. Every direction shows this faint afterglow of creation. It represents the oldest light in the universe, a baby picture when the cosmos was only 380,000 years old. Imagine drawing a wave on a deflated balloon. As you inflate the balloon, the wave stretches. Its peak spread farther apart. Its wavelength increases. Light traveling through expanding space behaves identically. When light leaves a distant galaxy, it carries precise signatures of hydrogen, helium, and other elements. These spectral lines appear at specific wavelengths that never change. Hydrogen always produces a bright red line at a specific color. But when this ancient light reaches Earth after traveling billions of years, astronomers discover something impossible. The familiar hydrogen line no longer glows at its normal red color. Instead, it appears shifted toward longer, redder wavelengths. Every spectral signature stretches. Scientists call this cosmological redshift. It differs completely from the Doppler shift you hear when an ambulance passes. Doppler shift happens when the source moves through space. Cosmological redshift occurs because space itself expands during the light's journey, stretching the waves like rubber bands. The amount of redshift directly reveals how much the universe has expanded since the light was emitted. A redshift of 1 means the universe doubled in size. A redshift of 2 indicates the cosmos tripled. The most distant galaxies show redshifts exceeding 10, meaning the universe grew more than 11 times larger since their light began its journey. This cosmic stretching affects different types of light dramatically. Ultraviolet light from distant galaxies arrives as visible light. Visible light becomes infrared. X-rays from ancient objects reach us as ordinary visible light. The stretching also reduces the light's energy. High-energy radiation from distant explosions arrives as low-energy radio waves. Even though distant galaxies actually blaze brighter than 1 trillion suns, they appear dimmer than candles viewed from thousands of miles away. Astronomers have measured red shifts for millions of galaxies, creating a 3-dimensional map of cosmic structure. These measurements reveal how matter clumped together over billions of years to form the galaxies we see today. In 1998, 2 teams of astronomers made a discovery that changed physics forever. They expected cosmic expansion to slow down. Gravity from all matter should gradually break the expansion that began with the Big Bang. Instead, they found the opposite. Expansion speeds up. This acceleration defied every prediction. For nearly 14 billion years after the Big Bang, gravity did slow expansion. Galaxy clusters formed as matter clumped together. The expansion rate decreased steadily. Then about 5 billion years ago, something changed. An unknown force began overpowering gravity on the largest scales. Scientists named this mysterious phenomenon dark energy. The name reflects our complete ignorance about its nature. We can't see it, touch it, or detect it directly. Yet this invisible force dominates the entire universe, driving the acceleration that will determine the cosmos's final fate. The evidence comes from studying stellar explosions called supernovas. These cosmic bombs all explode with nearly identical brightness, making them perfect distance markers. By measuring their apparent brightness, astronomers calculate exactly how far away they are. When researchers plotted supernova distances against their speeds, they expected a straight line. Instead, they found that distant supernovas appeared dimmer than expected. This meant they were farther away than simple expansion models predicted. Something had accelerated the expansion, carrying ancient galaxies to greater distances. The acceleration affects only vast empty regions between galaxy clusters. Within clusters, where matter density remains high, gravity still dominates. Dark energy can't overcome the gravitational binding that holds galaxies together. It only influences regions where matter density drops below a critical threshold. Current observations suggest dark energy makes up about 68% of the universe's total energy. Ordinary matter accounts for less than 5%. Dark matter comprises about 27%. This means 95% of reality consists of phenomena we don't understand. The nature of dark energy remains physics's greatest mystery. Some theories propose it represents the energy of empty space itself. Others suggest it emerges from extra dimensions. Still others argue that dark energy changes over time. Picture the cosmic inventory. Count every star in every galaxy. Add all planets, moons, asteroids, and gas. Include every black hole and exotic object astronomers have discovered. This entire collection represents less than 5% of what actually exists. The remaining 95% consists of two mysterious components that interact with ordinary matter only through gravity. Dark matter accounts for 27%. Dark energy makes up 68%. Neither component emits light or responds to electromagnetic forces. They remain invisible to every instrument we possess. Dark energy presents the greater mystery. Unlike dark matter, which at least clumps together, dark energy appears perfectly uniform throughout space. It shows no variation from region to region. It doesn't cluster around galaxies or accumulate in dense clouds. Instead, it fills every cubic inch of space with identical density. This uniformity creates dark energy's most puzzling property. As the universe expands and space grows larger, the total amount of dark energy increases proportionally. Double the volume of space, and you double the dark energy amount. This violates our normal experience with energy conservation. The energy density of dark energy is remarkably small. Each cubic yard of empty space contains dark energy equivalent to about 6 hydrogen atoms worth of mass. This seems insignificant until you consider the vast volume of the universe. The total dark energy exceeds the mass of all visible matter by more than 10 times. Scientists have proposed several candidates. The leading theory suggests it represents the energy of empty space arising from quantum effects. Quantum physics predicts empty space seeds with virtual particles that pop in and out of existence faster than light can cross an atomic nucleus. However, quantum calculations predict a dark energy density that exceeds observations by a factor of 10 followed by 120 zeros. This represents the worst prediction in physics history. Either quantum mechanics is wrong or dark energy has a completely different origin. Alternative theories propose dark energy emerges from extra dimensions or changes over time. Recent observations hint that dark energy might indeed be evolving, which would require completely new physics to explain. We began asking what the universe expands into. The answer reveals something profound about reality itself. The universe expands into nothing because it contains all the space there is. Space creates more space as it grows, like a cosmic magic trick that conjures its own stage. You are made of ray stuff. The atoms forming your body represent less than 5% of reality. The remaining 95% consists of dark matter and dark energy we can't see, touch, or understand. You exist as a temporary arrangement of minority particles in a universe dominated by invisible forces. Your existence depends on cosmic expansion happening at exactly the right rate. Too fast and matter could never have clumped together to form galaxies and stars. Too slow and the universe would have collapsed before life could evolve. The expansion rate balances on a knife's edge that permits complex chemistry and biological development. Every breath you take participates in cosmic expansion. The space between your atoms grows infinitesimally larger each moment. Though forces holding you together easily overcome this stretching, you remain intact while riding the expansion of space-time toward destinations no human mind can fully comprehend. The light reaching your eyes tonight began its journey billions of years ago when the universe was younger and smaller. You see ancient history stretched by cosmic expansion into the colors painting the night sky. Every star appears red-shifted by space's growth during its light's cosmic voyage. The expansion that began 13.8 billion years ago will continue for times that make the current universe age seem like an instant. Long after our sun dies, cosmic expansion will carry the remnants of everything we know across distances that dwarf today's observable universe. Perhaps this offers strange comfort. You exist during the universe's most interesting epoch when stars shine brightly and galaxies dance across cosmic distances. Your existence represents a temporary victory of organization over the cosmic trend toward increasing disorder. The mystery remains unsolved, but maybe the answer lies in recognizing that you expand along with it, thinking and creating meaning while space grows larger around you. Tonight, when you look up at the stars, remember this. You're seeing the universe's past stretched by billions of years of cosmic expansion. Every photon hitting your eye traveled through growing space to reach you. The atoms in your body formed in dying stars, scattered by expansion, then gathered again by gravity to create you. You exist during a brief cosmic moment when the universe creates complexity instead of destroying it. While dark energy drives everything toward cold emptiness, you think, feel, and wonder about your place in expanding reality. That might be the most remarkable thing of all. Consciousness arising in a universe that expands into nothing while containing everything. The expansion continues. The mystery deepens. And you're part of the story. If you want more tips like this, make sure you hit the subscribe button.